So there's more than one way to do things. And when I was presented with this code, the look on my face should tell you everything. But I can't even look at it. It's so bad. But watch. It can get worse. You see, there's more than one way to do things. And as you'll notice, this function name is even underscore one. And if you look over here, you'll see that I've got multiple other issues here, other ways of doing this that I've coded out. Because I've seen, when I've given this as an interview problem, I have seen people do the stupidest stuff. And what you have to understand is that this is not a skill everybody has. If you are a software development engineer and you get asked, how do I write a function to check if a number is even or odd based on a return value of a bool to see if it's even or not, it should be a very simple thing for you. And it's actually a one-line thing. But here are some of the things that I've seen in my career. This one right here. People try to get recursive. They try to show their knowledge. It doesn't end well. Because you look at this and you go, wow, what is the actual operational runtime complexity of this? And then you forget about negative numbers. That's also something that happens with this version, which is unfortunate, but it's they claim to be a better version of the prior one. I'm not so sure. Because let's face it, it actually doesn't even have the false there. But I've seen this given as an answer. Here's another version, to infinity, if number is blah, hard-coded question, just do it that way. Just use a truth table. Doesn't work. You should never do this. If somebody's writing code like this, they should not be allowed to program. It's that simple. This one's a little bit more interesting. It converts the number to a string and then checks the last character in order to look at the truth table and throw it in there. And what that does is it mitigates the risk of recursion, which can actually be a big problem on mobile devices, for example. But it's still not very efficient. And of course, you want a better version of that one. Just quickly checking and see if the return character is in a set of characters or not. And of course, if you're a data analyst, you're probably going to use this one and just import numpty and have numpty do it for you. But let's say you understand the modulus operation here and you actually understand the math. Well, maybe you'll be tempted to do this one. You're going to actually do the modulus operation by yourself instead of letting the compiler handle it. You might get the right answer, but you're not going to do it effectively. So maybe you'll want to check and see the last bit. Maybe that's really all you're looking for. Maybe you're checking for the last bit. And bitwise operations can be quick and fast in some cases. So that might be better. But honestly, the answer I'd be looking for is this. And this is important because from the perspective of there's more than one way to do things, my recommendation is that in that case, you should try to do it as effectively as possible. Because remember, code is read every day. And if the code is not understandable or it's too verbose, not only are you wasting cycles as an engineer rereading the same code over and over and over to do stupid stuff, but when it runs every time, you're just making the computer do stupid stuff too. And so if you're checking for is even in this case, then yeah, the one-liner that I talked about from the very first start of the video, which is this, by the way, is going to be the one that you're going to be willing to look for. But knowing this even doesn't make you competent enough to program, because there are scenarios like this where there are multiple ways to do the same thing in basically every operation you have to do as a computer programmer. In every single way, every single time you do some sort of mathematical operation or try to figure out scaling for a system. Now, in every case, I would expect this to be the correct answer. And if I saw any other thing in a code base, I would be questioning the employment of the individual who brought it to me, because unless they could show me with dedicated unit tests and performance metrics and everything else that was actually a better solution, I would be concerned that they were trolling me, but I would also be concerned that they may not be up to the task. And so the reason I've shown you all these different options using recursion, not using recursion, and so forth, is because every single one of these options has trade-offs, and not all of them are based on just the memory of the system it's running on. Some of them, for example, using recursion, that actually uses more power. And no, I'm not talking about CPU power. I'm talking about electrical power. Go ahead, go do the math yourself. Recursion actually scales out the memory usage, and it requires more electrical power to do, which is why recursion is not something that you should do on embedded devices or phones. In fact, if you have code that drains your battery really quickly that you have control over, say you're working on an app and you notice that it really does drain the battery, look for recursion. Remove the recursion, because guess what? That's probably killing your battery too. But this is bad for so many reasons, because you're counting down and you're also not taking into consideration the negative number situation. But at the same time, bad, bad, so bad, better, but still kind of bad. This actually was something that I had to think up just to make an edge case and show you just how weird it could be. This looks clean. You're just getting information from a truth table, but you're summarizing it down first. Well, still the wrong answer. Better version of that, but still the wrong answer. A lot of people, they'll reach for numpty. That is the wrong answer. Okay, that is inefficient. You should be not. The error here is that you shouldn't be adding dependencies. There is an additional dependency here that is huge that you just don't need. And so in your code, you should be looking to minimize your dependencies as much as possible. This is provided by the compiler. That is why you should do this way. And that will help, because it's a lot easier to understand this than to understand this. Okay, that's the error. The error is that a developer looking at this now has to rewind the stack in their head and figure out the mathematical operations. Don't make them do that. You should be writing clean, concise code, and you should be doing your best to make sure the person who can read the code is going to be able to do so. And if you try to come back and say, well, it's a skill issue on their part, no, it's not. It's a skill issue on your part, because you're not writing clean enough code. I like this answer, but because of how these operations are done in Python, I am not a fan of the lack of speed. The modular this operator is optimized to the point of, as much as it can. So I actually prefer this just because it's faster. It's got better performance in most cases. But the thing you should understand from all of this is that just because there's different ways of doing things doesn't mean that there isn't a best solution. You as an engineer should be striving for the best solution at all times. And if you happen to go through and maybe you got a part of the project that looks like this, maybe it technically works, but it's the slowest option and the most energy intensive option for the computer to run. Maybe you should go back and do some profiling, validate that, and then replace it with this version. It's going to be faster. It's going to take less energy. Your phone battery will last a lot longer. But ultimately, at the end of the day, it's about being a good engineer. And as you think about system design, everything that you do is a different version of replacing this function. If you've abstracted your system out to components and services, and you actually understand the interfaces involved, then swapping out this simple function is going to be easy, just as swapping out a service or component in that system will be easy. When you think about system design, try to think about replaceable components, or in this case, if it's easier for you to think about, replaceable gears. Think of it as a watch, okay? You might want to swap out one of the gears because it's made of brass. Maybe you want to swap out the gear and switch it with something made of titanium just for fun. Well, guess what? If it's the same size and has all the same measurements, you can do that. But it's got to fit in there. It's got to have the same function signature in this case. But it could just easily be a different interface that you defined elsewhere. The important thing is that we have different versions of the is even function here. And I've shown you that there are multiple different ways that that work can be done. But we have a common interface. Granted, I've renamed these, but the function signature is the same. It's a function, takes in a number, returns a Boolean. Think like that, and your designs will be better and easier to work with.